now let's do another overlapping set problem involving percents, but this time let's do one that uses both percentages as well as discrete values. Last Saturday, 60% of attendants at a certain movie theater bought popcorn and 45% bought nachos. What was the number of people who bought both popcorn and nachos last Saturday? And the real question is, why is this number not 100%? Because if you buy both popcorn and nachos, you can dip the popcorn in the nacho cheese, and it's like you have two types of nachos. But we are not here to judge these people's snack buying preferences. We are here to mathematically analyze them. So we have an overlapping set scenario here. We got popcorn eaters and non-popcorn eaters. And we got our nacho eaters and our no nacho eaters. And so they start off by giving us these percentages here. But then in the question, they say, what is the number of people who bought both popcorn and nachos last Saturday? So the fact that they're looking for a discrete number means we cannot just assume we had 100 people go to our movie theater last Saturday. I also see in the second statement, they give us a discrete number of 500 people. And so because of this, we are going to have to make accurate translations for each of our boxes. And you have to do this sometimes with these data sufficiency questions. You have to look ahead at the statements to make sure that they don't give you any discrete values, or in this case, that they do give you discrete values. So here, when we start filling in, we're going to have to, we can't just put in 60 and 45 into our boxes. So last Saturday, 60% of attendants at a certain movie theater bought popcorn. So what that means is we have some number of total people, say T, who attended our movie theater. 60% of them, so that is 0.6 T, got popcorn. And if 60% bought popcorn, 40% did not get popcorn. So that's 0.4 T. 45% bought nachos, and so that would be 0.45 T here, which means 55% of my movie theater attendees did not buy nachos. That's 0.55 T. This is all information from the prompt, and so I've circled this because it's universal and applies to both statements. What was the number of people who bought both? And so this is the box that we are looking for. Statement 1, 15% of the attendants bought neither popcorn or nachos. So that's 15% of my total people. So that means this box here should be 0.15 T. And that means 25% of my people bought nachos, but no popcorn, because this is 0.25 T, because this box here plus this box here has to sum up to 0.4 T. So this information is both from statement 1. So I'm going to put a little 1 in the corner here. So what does this mean? So based on this, we can say the people that got popcorn without nachos should be 0.4 T, because got to sum to 0.55 T here. That means this box here, the box that we're looking for, is 0.2 T, or 20% of my people bought nachos but no popcorn. But they're not asking for the percentage of people. They're actually for the actual number of people who bought popcorn and nachos. And so this first statement, while it does get us to a point, we can sort of rephrase our question from this first statement, because if we're looking for 0.2 T, then the information we need to answer that question is just the total number of attendees. Without knowing that information, we cannot go any farther. So this statement is going to be insufficient, even though it does get us close. Statement 2. So for a second, we gotta forget that we know this stuff. 500 people attended the movie theater last Saturday. So that is my total people. And so everything we have circled is in terms of t. So if we know this t is equal to 500, we should be able to fill out all of these boxes, all of our subtotals. Sometimes I call these the gutter of our table. And usually when all you can fill in is the gutters, you can't do much with it because you can't get anything else additional other than the subtotals. So knowing just that is not going to help us get to here. Remember, we don't know that this is equal to 0.2t anymore. That was from the first statement. And so second statement is also going to be insufficient. And so now we got to look at them together. And so remember, our first statement allowed us to just rephrase our question because we're looking for 0.2t. So we're just looking for the total number of attendees. And then the second statement, it gave that to us. And so based on that, without even having it calculated, you should know that together they are sufficient. If we wanted to calculate, and in fact, it looks like we'll be able to fill in our entire table if we wanted to, we could do that. And so let's just do that for the sake of completeness. And so if we had 500 people total and 20% of them got popcorn and nachos, that's 20% is 1/5. So that's just 100 people, which means if 2/5, 40% of my people are here, that should be double this, right? Yes, 200 people. Which means 300 people, so 60% got popcorn overall, and so that's 300, and 300 over 500 is 60%, which means 200 or 40% did not. Where's this number here? So 25%, that's going to be 1/4 of 500. What is that? What is 500 over 4? $125. So 125 here, which means 75 here. So far, everything looks like it adds up. So 225 here. 225 over 500 is 45%, so that checks out. And this should be 275. So we didn't need to fill in all of this information to answer a question. But I say when you're reviewing and you have the time to do it, why not just practice your arithmetic skills? So the answer here, though, is C.